I'm Breezy Ocaña Flaquer, and I'm going to talk to you today about the low-tech and high-quality correlation in astronomy education. And I want to emphasize the astronomy education part because, of course, astronomy is a science that depends on technology. And not only depends on technology, when the technology doesn't exist for what research needs, then we develop our own technology that sometimes is then used by the general public. An example of why we need to develop technology in astronomy is this research that just came out in 2021 from Moravito et al. So this is the LOFAR telescope, the low frequency array. What you see on the right, it's an image of an astronomical source with standard resolution. But we needed to understand better what's going on. We need to see more details of what's going on. So we developed the technology for having a higher resolution image. And this is the difference it makes. Look at all the details we can get out of it. But in schools, in early education, it is a different story. We need to first go back to basic and understand astronomy from the beginning. We need to observe our surroundings. We need to pay attention, ask questions, play, create, observe, think. And for that, we don't need the technology. Why to use or even consider a low-tech approach when astronomy is such a high technological science? Well, the amount of technical knowledge and skills that are required for handling high tech can be intimidating, both for the teacher and for the student. It also has an enormous impact in breaking down walls and making science fun, interesting, and approachable. And because independently of the teachers and the students' background, the students become scientists who sometimes even develop their own instrument. This empowers them. An example, it's measuring the shadows. Just by measuring the shadows, there's so much we can learn. We can follow the shadow throughout the day and understand how the sun is moving throughout the day. We can do this several times during the year and observe how it changes during a year and how the sun changes in the sky during the year. We can find the local noon, and we can even measure the circumference of planet Earth, like Eratosthenes did. We have done NASA workshops in the Dominican Republic. NASA is a network for astronomy school education, and they teach a course on didactic astronomy to teachers. Astronomy, it's included in the curriculum, maybe not as a topic on its own, but there are topics of astronomy in natural sciences, in social studies, or in physics when they're like in high school. But most of the time, the teachers don't have the knowledge of astronomy or the tools, or so they think, right, to teach astronomy. And NASA provides the teacher with this material. As you can see in the map, we have, during the NASA workshop, there has been teachers from pretty much all over the island. And the really important thing about this image is that, yes, the two most important cities are the two cities that had the most teachers, but you can see that there are teachers from other places other than the two major cities. And they don't tend to have a lot of access to technology or even to higher education. So this really helps the teachers. One thing that I really like about the NASA workshops is that they use materials that are accessible, approachable. Maybe you have them at home or in the schools. And if you need to get something, it's really easy, cheap, and accessible. It's things that you can use in everyday life. And with that, you can study astronomy, astrophysics, astrobiology. So you can really go deeper into the science without needing to go to a higher tech instrumentation, for example. These are examples of the activities either by NASA or other activities that we have done that come with a lot of learning. For example, the parallel Earth, we can talk about the seasons and And in the extreme, the poles, why half of the year you have no sun, and then you have no night. And you can explain these to kids, show them, and it's easier to understand. We can also build our own planetarium, and we can talk about why the sun has different colors in the skies, depending on how high it is. Those are examples. We can also talk about the decomposition of light, the different colors of light. We can measure the time using a sundial. We can calculate the diameter of the sun. We can build our own instrument to determine the elevations of objects. If we're lucky enough to be in the tropical areas, we are able to experience the zenithal pass of the sun. And so we are able to experience no shadows. And you can use this as an excuse, right, to teach a lot of astronomical information to our students. After the NASA workshops were performed in the Dominican Republic, we sent a form to the teachers, and we asked them to fill this form and to give us some feedbacks. One of the questions that was asked in this form is how useful they thought this course was. Their options for the answers were that the course was very useful, useful, somewhat useful, and not useful. So most of the teachers answered that it was very useful, and just 5% answered that it was useful. This is good because we're talking about that a place where most of the teachers that came to this course would not have access to technology, and the fact that they find these activities and information very useful, it's good because now they have the tool to teach their students. I taught the same course in the United States, and the same form was sent to the teachers with the same questions. And again, the question of how useful was this course was sent to them. The answers, the options to answer were the same. And it's important to compare these two results because the approach to education is different. Comparing public schools, right? In the United States, you have a lot more access to technology. Teachers tend to be much more prepared in technology than they are in the Dominican Republic. I'm talking about public schools and generalizing, right? And the students also have more access to the technology. And so when you ask these teachers about how useful they thought this course was, 83% answered that it was very useful, and only 16% answered that it was useful. What you can see here is that no matter what your background is, they thought that the course was useful and they could use this with the students. After some time, after the first NASA workshop, and with teachers that have participated in other activities, and with teachers that generally teach astronomy in the Dominican Republic in one way or the other, we sent out a form so that they can answer some questions. And in these questions, we ask about the level of technology they thought those activities were, if they had low technology, or if they used a low-tech approach or a high-tech approach. And we also asked them how they thought the students performed, if they didn't comprehend the material or if they had a high comprehension of the material that it was taught. And this plot the size of the circle. The bigger the circle is, the more data point we have. And we can see here that the part of the biggest circle of all goes to the part that has a low-tech approach with high comprehension. We can also see that there are points where you have high-tech approach and also high comprehension. And this is okay. I mean, some teachers have a lot of knowledge of technology. They may use this technology, and maybe the students are more exposed to technology, and there is a high level of comprehension. Why not? But what we can see here, and what it's important, is that most of the teachers and most of the activities were in the lower low-tech of the plot with higher comprehension, which implies, again, that we do not need to have high tech in order to have a high comprehension of the material. In conclusion, a low-tech approach does not mean low expectations or low standards. Throughout all the activities, we have maintained high level of technological concepts and skills trainings. We have provided many hands-on materials, and there has been small learning communities that were created which serve to boost confidence, maintain engagement, and provide a platform for clarification and deeper level of understanding. Thank you very much for your attention.